everyone! The equation of a hyperbola. This is Miss Oshier.
Miss LaHart.
And here we go.
Hyperbola. It's so fun to say.
Hyperbola. Okay.
Hyperbola.
This is what a hyperbola looks like.
Ooh, that looks
not a parabola.
intimidating.
It's a hyperbola.
It looks intimidating.
It's basically an ellipse, but rather than connecting, it goes opposite ways.
Mm-hmm.
It has two branches. The vertices are located on the endpoints of an invisible line segment called the transverse axis. You want to think transverse axis is the same thing as the major axis. Okay? Center is located right same place.
Mm-hmm.
Conjugate axis, you want to think minor axis. And each branch of the hyperbola approaches but does not intersect a pair of lines called asymptotes. These are new, people. This is the new part with hyperbola. So these crisscross lines, those are asymptotes that will always cross through this imaginary box that's made between your transverse and conjugate axis, which you can refer to as major and minor in your brain. Not out loud. Okay. Fun fact. The difference of the distances from any point on the hyperbola to the two foci equals the length of the transverse axis. So with ellipse, it was the sum of those distances. With the hyperbola, it's the difference. Okay. Whew. So this is just another rundown of everything that we're looking at, okay? Your center's still at HK. So HK in this case. What's different with the hyperbola is, you know, with ellipses we would put A just under the bigger thing. Order matters with the ellipse because you have the minus. So if it's a y minus x, your big value is going to go most likely with the y. But it just depends. If y minus x is here, those values stay with the y and the x, et cetera, et cetera, et cetera. So that matters. The other new thing are the equations of the asymptotes. These are in point slope form because they're a little bit easier. Essentially, you just plug your vertex in and then you give your b over a value.
Yep.
Okay? And we'll use these more and more and more. So let's sketch the hyperbola. We know its center is at negative 5, 4.
Okay.
B,
I got that.
Careful.
I see that the y is leading.
Transverse axis is a line. So you might be like, what are you talking about? Transverse axis is x equals negative 5. Remember, that's a line. So the vertices are going to be, of our transverse axis, 6 units away, just like they were before, this point. So I go up and down. But I'm going through the line x equals negative 5.
Yep. Okay, and then the other one would be, 3.
Yep.
I'm going to do that yet.
Oop. So then we have c squared equals a squared plus b squared. So c squared is 45. So I'm just getting the foci done with while we're chatting. Boom.
Okay. So 3 out because 9 squared, 3 squared is 9.
Yep.
So that's why we went 3 out. We made our little box.
Our little box.
Okay. Our asymptotes will go through the diagonals of those boxes.
Boom.
And then from there, you just create your beautiful looking hyperbola.
Yep. And now you know it's going up and down versus left and right because the y is first.
So it's all about making your pretty box.
All about making the pretty box. Rise, run. So as far as getting your equation of your asymptotes, your slope is going to be rise over run. Well, notice that's the a value over the b value over the a value. So 6 over 3. Boom.
Leave it like that. Or simplify.
Yes.
All right, just like before, this is not like the form, but remember that right side has to be equivalent to 1. So if you divide everything by 400, that's what you yield. Meaning my center point, I got it 0, 0.
Woo!
That was tough.
So we're going to go over 4, right 4, up 5, left 5.
Boom, 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 boom. Oh,
Foci.
the foci.
Okay, we're just going to leave this up. These are calculations you need to find. You should be somewhat comfortable with foci now because we did ellipse, but this is what we're doing. Okay, so we have the box, we have our asymptotes. Now this one's going to be going because x is first, left and right. And our asymptotes, because it was 0, 0, are just going to be y equals 5 over 4. Remember, it's always the bigger number over the little number.
Woo! Okay. Oh boy. All right, complete the square.
You should know how to do this by now.
Get everything over the constant term over to the right side. Take out your leading coefficients of your squared terms.
Divide by 2 and square. Negative 6 divided by 2 is negative 3. Squared is 9. 4 divided by 2 is 2. Oh, sorry. Then don't forget it's 9 times 12, so 108 over on this side. 4 divided by 2 is 2. 2 squared is 4. 4 times negative 4 is negative 16. Be careful of that negative.
That's a good one.
And then we're going to divide by negative 48. So that's going to change this to negative blah, 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 plus blah, blah, blah. Now I'm saying blah, 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 because I'm saying, hey, there's a negative here. This looks like an ellipse right now, but it's not because it's minus. So we have to rearrange it so that it looks
that's tricky.
Standard form. Okay.
All right, but not so tricky. So from this, I know that my center point is positive 3, negative 2.
Boom.
I also know that on my y, I'm going to go up 2, down 2. And then right and left, I'll go the square root of 12.
Getting there, slowly but surely.
Okay. Foci. Ooh, look at that.
Boom. So again, square root of 12 was how we got those other values, so we approximated where that would be. Okay. Boom. 4 over 12. And I'm sorry, I think I said it's always the big over the small. I didn't mean that. I meant it's always the A over the B. Okay? A is found under the Y, B is found under the X. That's what I meant to say. Pretty sure. We'll figure it out. I think it's B over A. Let me go back, because I change things all the time in my PowerPoints. But this is why you have notes, people, so you can go back and reference your notes. Okay, it's B over A or A over B. That's why. So if we go back to this, for a transverse axis that's going left and right, it's going to be B over A. So Y over X. Here, because remember, it's rise over run. It's A over B because it's rise over run. So it's always what's under the Y over what's under the X.
There we go.
There we go. Sorry if I misspoke. I apologize.
Oh, it's going to be anarchy. You know that.
Anarchy.
Anarchy. Okay. So it's always Y. That's why this was 4 over 12.
Bam. Bam. Okay. Last one. Okay. Find the equation of hyperbola with center at negative 1, 0 and focus. So we're going backwards, people. Okay. Remember, plot what you have and try to figure it out from there. So if I have a center here and my focus is at negative 11, 0, but my vertex is at 5, 0, well, that's a lot prettier of a value for me to deal with. Okay. I know that this is going to be my transverse axis, so I know that I'm going to have this value underneath my x-axis, my x-coordinate.
The distance from negative 1 to positive 5 is 6.
Yeah,
so
be
6
careful.
squared is 36.
It's not 5 squared. It's negative 125.
And then we figure out they've given us the distance from the focus to the center, so we use that 10 value over at the C part. C squared equals, A squared plus B squared. And you do the math,
And there we go.
And that's it.
And we will see you in class. You just got to work through it. It's a bunch of rules. You guys will be fine. Have a great day.